Newton's
laws
of
motion.
Sir Isaac Newton was born December 25th, 1642.
He died March 20th, 1727.
French writer Voltaire first recorded the story that a falling apple gave Newton the inspiration for his theory of gravitation.
Sir Isaac Newton proposed the theory of universal gravitation,
Which explains that all bodies are affected by the force called gravity.
In 1704, Sir Isaac Newton published Optics, describing his theory that white light is a blend of different colors.
Newton was reluctant to share his research with other scientists for fear they would take credit for his discoveries.
Formulated the three laws of motion which describe classical mechanics.
Sir Isaac Newton is partly known for inventing the branch of mathematics known as calculus.
In 1661, Sir Isaac Newton entered the Trinity College in the University of Cambridge.
Fun facts about Sir Isaac Newton.
And his laws of motion.
Every object in a state of uniform motion tends to remain in that state of motion unless an external force is applied to it.
Okay.
I'm on this side, speak asshole.
When I throw this, if it wasn't for gravity and air resistance, it would have stayed flying forever. In space, it would have stayed flying in the same direction, the same height, the same speed. It wouldn't have stopped unless it was for the unbalanced
Well, the nose cone is
reaction.
Car.
Unbalanced thing.
Got a missile.
I don't know. But how... If it wasn't for gravity, these leaves, when I throw them, would stay up in the air. But because of gravity, they fall. Probably why all the leaves fall after in the winter. The leaves die, they become loose, and they just fall. I've got a ton more of these in my pocket, and they're not coming out. Just kidding, maybe it was just one.
An object at rest tends to stay at rest, and an object in motion tends to stay in motion, same speed and direction, unless acted upon by an unbalanced force.
So Shannon's going to be kicking her shoe. And that explains how if there was no air resistance or gravity, that shoe would keep going on forever, and if it didn't hit the wall, which is an unbalanced force, it would just keep going and going forever. The relationship between an object's mass, its acceleration, and the applied force is called inertia. Acceleration and force are vectors. In this law, the direction of the force vector is the same as the direction of the acceleration vector.
No, I swear.
Okay. I'm like dying.
Okay, so what we just did was explain that how if the skateboard is empty, you don't have to admit a lot of force, but when there's more weight on the skateboard, you have to add more force to pull the skateboard. So when Melanie was on the skateboard, it wasn't as hard as when Marty was on the skateboard with the cinder block.
The acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object.
For every action, there is an equal and opposite reaction. Working with Newton's third law of motion, these two tennis balls with the same size, shape, and mass, when put in contact, they have an equal amount of force and an opposite reaction going opposite ways.
As you can see, Chelsea is giving a lot of force to the wall, by which the wall is giving a lot of force back. But as you can see, Rihanna is giving very little force and is receiving very little force back.
As you can see, Chelsea has stolen my chair, and I would really like to get my chair back. So what I'm going to do is I'm going to use force to try to get Chelsea off my chair. And she is using force back, which is making it pretty difficult to get off the stool. So what I'm going to do is I'm going to use more force and get her off my stool. Okay, so Chelsea and Shannon are standing and explaining the third law of motion. They are putting force down on the ground, and the force is pushing back up on them, or else they would just fall through the ground.
For every action, there is an equal and opposite reaction.
Okay, so in our attempt to hit this over the head with John, this poor apple got hospitalized, okay? And we had to bandage him up because he's split in 4 different places. What are you doing?
This is our apple, Bob. That was
His name's Philip.
Philip? Okay, Philip.
Fred.
Fred the apple that died in our findings of Sir Isaac Newton.
Ready?
So we pay our dues to our friend Apple
Hold on, no,
Bob.
ready? Watch.